basically Tesla is aiming to be the best at manufacturing of any company on earth. Hej og velkommen til eller tilbage her til dagens pengetips, hvor vi i dag skal snakke om et af mit favoritemner, nemlig Tesla. So, what tends to happen as companies get bigger is things tend to slow down. Actually, they're going to speed up. I går, som jeg optager den her video, der afholdte Tesla deres Battery Investor Day, som for mange var lagt op til at blive den største begivenhed nogensinde i Teslas historie. I think it's pretty nice that investment per gigawatt hour reduction is 69%. I mean, who would have thought?
Yeah, just happened to happen out that way.
I mean, 0.420%, of course.
Jeg sad faktisk oppe i sofaen her i går aftes for at se den her live, som det kom ud sent om aftenen her i Danmark, men faldt desværre i søvn, da den første times tid bare gik med noget kedeligt shareholder stuff og noget afstemning osv.
Thank you, Al. Hello everyone and welcome to the 2020 Tesla shareholder meeting.
Og det er altså først efter en time cirka, at Elon gik på scenen, eller midnatstid i går aftes. Så jeg valgte at gå i seng for at kunne se det, når jeg kan spole lidt i det. Men i dag, der vil jeg se Battery Day. Jeg vil vise nogle klip her i videoen.
Actually, I don't know how we're getting the questions.
Actually, I don't know either. Is somebody going to read them to him? Okay, well, you could just you can maybe get out of the car for 2 seconds and yell it at us. I don't know. Hey, how do we get the questions?
Jeg vil give mine reaktioner. Og fortælle det vigtigste, som du skal vide fra Tesla Battery Investor Day, og hvad det betyder for Tesla som virksomhed, for deres fremtid, og ikke mindst for dig som Tesla-investor, hvis du ligesom mig investerer i Tesla.
But I think also for long-term competitiveness, eventually every car company will have long-range electric cars. Eventually every company will have autonomy, but not every company will be great at manufacturing. Tesla will be absolutely head and shoulders above anyone else in manufacturing. That is our goal.
Jeg har prøvet så vidt muligt ikke at se noget som helst omkring, hvad der er sket til ventede, men det har været svært helt at undgå det. Og jeg kan også godt se, at Tesla lige nu er nede i pre-market, altså aktiekursen står til at falde i dag, hvilket er meget forventeligt, fordi der er rigtig mange, der slet ikke forstår, hvad der bliver fortalt og præsenteret, og hvilken effekt det har i fremtiden.
What does this mean for our future products? We're confident that long term we can design and manufacture a compelling $25,000 electric vehicle.
Nu har jeg selvfølgelig ikke set det selv endnu, men vi har set det tidligere med Teslas keynotes, f.eks. med Cybertruck osv., hvor aktiekursen først falder, fordi der er en masse hype. For det første så er det det her med at buy the rumor, sell the fact, så man køber med forventning om, at det stiger til Battery Day, og når Battery Day så er kommet, så sælger man. Så formentlig er der mange, der er solgt ud nu, fordi de håbede på en hurtig gevinst, men for os langsigtede investorer, der er sikker på, at Battery Day det udelukkende betyder gode fremtidsudsigter, gode nyheder og potentielt en opkøbsmulighed. Så lad os stoppe snakken og komme i gang med at se på Tesla Battery Day og hvad Tesla har at sige.
So we have and extreme performance and range. We should probably talk about the Model S Plaid. What about that?
We will now continue with the company update and year in review. And it's my pleasure to introduce Tesla co-founder and CEO, Mr. Elon Musk.
Hvis du undrer dig over, hvorfor der er så mange, der dytter, så er det fordi, at det her det er jo stadigvæk corona, og især i USA også. Så deltagerne her til ventede, de sidder alle sammen nede på parkeringspladsen i deres egen lille Tesla-bil.
Well, I mean, this is definitely a new approach. We got the Tesla drive-in movie theater, basically. It's good to see everyone. It's a little hard to read the room with everyone being in cars, but it's it's the only way we could do it. So. Hopefully it's cool, and hopefully you can hear me. Can you guys hear me? Okay. All right, great. All right, well, thanks for coming.
Herfra der vil jeg så lige kun lade de vigtigste bidder blive i videoen, og ellers give nogle kommentarer undervejs.
From, in terms of our ability to create a factory, huge kudos to the Tesla Shanghai team for being able to go from literally a dirt pile to volume production in 15 months. It's like, damn. Yeah.
Så det her er seriøst verdensrekord og virkelig vildt, at Tesla de har kunne bygge en fabrik fra ingenting til volume production på 15 måneder, altså fra ingenting til en kæmpe stor, nogle af verdens største bygninger, der kan producere i øjeblikket, tror jeg, omkring 500.000 biler om året på bare 15 måneder. En af de vigtigste ting ved Tesla, det er også, at det sværeste at bygge, det er ikke maskinerne, bilerne, det er maskinerne, der laver maskinerne. Og at Tesla hele tiden bliver så meget bedre til at bygge deres biler, så de kan lave flere biler, de kan bygge flere fabrikker, de kan gøre det hurtigere, de kan gøre det billigere. Det er altså en af de kæmpe store, vigtigste egenskaber, der er ved Tesla, og hvorfor at de vil komme til at udkonkurrere så mange andre af de klassiske gammeldags bilfabrikanter.
You know, we really try to tell these companies, hey, you really need to do this, or you won't exist in the future.
Fordi Tesla, de hele tiden rykker hurtigere. De bevæger sig med en eksponentiel kurve, og de lærer deres fejl, og de implementerer det og lærer fra det med det samme. Det bliver spændende at se, hvor hurtigt det går med fabrikken nede i Tyskland, og hvornår at vi kan begynde at se Model Y'er her i Danmark produceret nede i Tyskland.
And I think something that's really quite noteworthy here is Tesla is the only foreign manufacturer to have a 100% owned factory in China. Foreign factory in China is a really big deal. Over time, a factory that produces over 1 million vehicles a year. The hardest thing is scaling production, especially of a new technology. It's insanely difficult. Making a prototype is relatively easy. Tesla was really the first company in about a century in the US, the first US company in the US to reach volume production and be sustainably profitable. Like the crazy thing is this has really not happened in 100 years. And we now have 4 vehicles in volume production, S3XY. So also the toughest joke, I think maybe ever. It was a very difficult joke to make.
En ting, som du sikkert godt ved, men det er, at Teslas biler, det er Model S, Model 3, Model X og Model Y, og det staver selvfølgelig sexy. Det var egentlig meningen, at Model 3 skulle hedde Model E, men det ville Ford ikke tillade. Så det har altså været rigtig svært for Elon at prøve at lave den her joke med at skrive sexy, og hvis du kigger på nogle af de fremtidige biler, der kommer ud, så vil du også kunne se, at de vil stave ordet cars, altså sexy cars. Og det er noget af det, jeg synes, der også er så fedt og sjovt ved de her Tesla-biler, og det er også det, man oplever, når man prøver at sætte sig ind i en og køre i en, at man kan virkelig se, at de har det sjovt med det, og at de laver de ting, som brugerne gerne vil have, uden at man nødvendigvis selv ved det, men der er så mange Easter eggs og alt muligt rundt omkring, som bare gør det til en leg og en ny oplevelse hver eneste gang, man kører en Tesla. Og det er altså super fedt, at der ikke er alt den her bureaukrati og sådan noget, men at de laver de ting, som der bare er fede at lave.
We also introduced the lowest cost solar in the US. It's only $1.49 a watt, so reduced sales and advertising. It got rid of a bunch of unnecessary costs. And we also got 4 consecutive quarters of GAAP profitability, which was very difficult. The future is looking like I think very promising from sort of an annual profitability standpoint. Do well financially. You really need economies of scale, and you need ideally the best technology. And I think we've had the best technology for a while, but now we are also achieving economies of scale. You know, I think the value of Tesla is going to be like total, just on the vehicle side, total vehicles produced times the value of autonomy. That's a way to think about the future value of Tesla. We also have consistent free cash flow generation. So having a factory in China that's able to serve China and then, soon many other countries in the region will be key to us.
Nu er de i gang med at bygge i Berlin og i Texas til henholdsvis Model Y-produktion til Europa og til Cybertruck-produktion i USA. Og formentlig vil vi også snart se noget produktion af semi- og roadsters. Så der kommer til at blive bygget rigtig mange nye gigafactories, og du kommer til at se, at produktionen af Tesla-biler kommer til at vokse eksponentielt, så der bliver bygget flere og flere fabrikker, der kommer til at producere flere biler hurtigere og billigere.
Industry performance, while the rest of industry has gone down, Tesla has gone up. I think this speaks to... Thanks.
Ja, der er ikke så meget mere at sige til det. Mens alle andre bilselskaber er gået tilbage i den sidste stykke tid på grund af corona osv., der har Tesla altså formået at ikke nok skabe overskud i 4 kvartaler i træk, selv i de svære tider og med fabriknedlukninger. De har altså også haft fremgang modsat alle andre bilvirksomheder, selv i coronatider.
Our sales, as Al was saying, really grow by word of mouth. It's growing on the basis of existing owners recommending it to new customers. This is really, I think, a good way to grow. And then in 2019 we had 50% growth, and I think we'll do really pretty well in 2020, somewhere between 30 to 40% growth, despite a lot of very difficult circumstances, we were able to still see significant growth in one of the most difficult, in fact, I say probably the most difficult year of Tesla's existence. It's worth looking at like the average life cycle emissions in the U.S. And just how much better a Tesla is than, or an electric car, than any other, than any kind of gasoline car. We also have safety at the core of our design. The Tesla cars are the safest cars ever designed. We have the lowest probability of injury of any cars ever tested by the U.S. government, and that's just passive safety. When you add active safety into that, it's even better. If safety is important to you, which obviously it is, the safest car you could drive is a Tesla. Safety is paramount. It is actually the #1 design objective when we build a Tesla is safety. The U.S. average for collisions is at roughly 2.1 per million miles, and with autopilot engaged, it's 0.3. I mean, this is a profound difference. It really massive, and this will get even better. We're now labeling in 3D video. Now, with our new labeling tools, we label it in video. So we actually label entire video segments with the surround video and with time. So it's now taking all cameras simultaneously and looking at how the images change over time and labeling that. We'll hopefully release a private beta of Autopilot, or the full self-driving version of Autopilot, in I think a month or so, and then people will really understand just the magnitude of the change. It's profound. I call it like 4D in the sense that it's 3 dimensions plus time. Tesla core competencies, we've got engineering, obviously. But also manufacturing. I think manufacturing is underappreciated in general. The difficulty of designing the machine that makes the machine is vastly harder than the machine itself. Making a Model 3 or Model Y or Cybertruck prototype is really quite trivial compared to designing the factory that makes it. It's just at least 10 to 100 times harder to do the factory than the prototype. And that's why you see a lot of companies out there or startups, they'll bring out a prototype, but they just can't get it over the hump for manufacturing, because manufacturing of new technology especially is the hardest thing by far. At best 10% of the difficulty and probably closer to 1%. And then software. Tesla is both a hardware and a software company. A huge percentage of our engineers are actually software engineers. And you can think of our car as kind of like a laptop on wheels.
Der er virkelig så mange guldkorn af Elon Musk her, så jeg vil prøve at lade være med at kommentere alt for meget for at afbryde det. Men det her med, at Tesla er en softwarevirksomhed, der desuden har stærke kompetencer for engineering og for manufacturing, det er altså virkelig vigtigt. Og som Elon Musk siger, så Tesla, det er ikke en bil, men det er en computer med hjul på. Og det vil du også opdage. Jeg var faktisk ude at prøvekøre her i weekenden Audi og Folkevogn elbiler, og der var ingen sammenligning med Tesla. Det føles mere som at køre en normal bil, som har fået en elmotor, hvorimod når man kører en Tesla, så kører man en Tesla. Og du ved det kun, hvis du har prøvet at køre en Tesla. Jeg har engang læst, at der findes 3 typer af mennesker. Dem, der ejer en Tesla, dem, der drømmer om en Tesla, og dem, der aldrig har prøvet at køre en Tesla.
With each factory, what we're trying to do is also improve the manufacturing technology. So, in some cases, like the Model Y made in Berlin might look the same, but it actually is made in a much more efficient way. Yeah, launched Megapack. It's a 3 megawatt hours all-in-one energy storage solution. So it's been great overall. In addition to the battery stuff, we got a few extras as well. So I think you'll really like what we have to say on batteries. The battery stuff we're going to talk about is truly revolutionary and essential to Tesla's goal. The fundamental good of Tesla. It's like if you look back in history and say what good did Tesla do? The good will be to by how many years did we accelerate sustainable energy? That's like the true metric of success. What good did Tesla do? The good will be to by how many years did we accelerate sustainable energy?
Hello, everyone. I'm Drew Baglino, SVP of Powertrain and Energy Engineering at Tesla, and I'm incredibly excited to talk about what we've been doing at batteries here at Tesla.
So let's see, you got the clicker?
Yeah, I've got the clicker, yeah.
Okay, let's I'll take it first, perhaps.
Sure.
So obviously the issues we're facing are very serious, with climate change, and we're experiencing these issues on a day-to-day basis. It's incredibly important we accelerate the advent of sustainable energy. Time really matters. This presentation is about accelerating the time to sustainable energy. The past 5 years were the hottest on record. It's obviously, this time is not like the past. It's really important that we take action.
Especially when it's just a transitory one anyway.
Yes.
We're going to run out of these fossil fuels. Let's just move to the future and not run this experiment any longer.
Yeah. Talk a bit louder.
You got it.
Okay. There is a lot of good news, though. Now, it's also worth noting that the length of time that power plants last is on the order of 25 years. So even if 100% of energy generation was sustainable, it would still take 25 years to convert the grid. Power production from coal has dropped in half. So it went from 46% of electricity in 2010 to 23% in 2020. So this is a massive improvement. So good things are happening on a lot of levels. We just need to go faster. So in terms of Tesla's contribution, we've delivered over 1 million electric vehicles, 26 billion electric miles driven, many gigawatt hours of stationary batteries, 17 terawatt hours of solar generated. Underweighted at Tesla, but it is a massive part of our future. The three parts of a sustainable energy future are sustainable energy generation, storage, and electric vehicles. So to accelerate the transition to sustainable energy, we must produce more EVs that need to be affordable and a lot more energy storage while building factories faster and with far less investment. Goal number one is a terawatt hour scale battery production. Tera is the new giga.
Yeah, and you can see we're talking about 100x growth in batteries for electric vehicles to achieve this mission. And we are going to get there. It's just a matter of how fast, and our intention is to accelerate it.
You basically need on the order of roughly 10 terawatt hours a year of battery production to transition the global fleet of vehicles to electric.
And the average vehicle lasts 15 years, so we're talking about 150 terawatt hours, give or take, to transition the whole all vehicles of all types to electric.
Yeah, so it's a lot of batteries, basically. So today's batteries cannot scale fast enough. They're just too small.
We would need 135 fully built out Nevada gigafactories to achieve 20 terawatt hours a year. It's not scalable enough of a solution. We need a dramatic rethink of the cell manufacturing system to scale as fast as we can and should.
So, and then goal two, obviously, we need to make more affordable cars. One of the things that troubles me the most is that we don't yet have a truly affordable car. And that is something that we will make in the future. That's why we got Battery Day.
Yeah. To make the best cars in the world, we design vehicles and factories from the ground up. And now we do this for batteries as well.
Yeah. It's weird, the slides don't show up quite right. Anyway, what shows up on the screen is not quite what shows up there. Anyway.
Oh, okay.
It's different.
Yeah, I think it's because that's... Yeah.
No, that one's current, supposed to be current. Anyway.
So, let's get started.
Det er virkelig sjovt, at det her det er verdens mest værdifulde bilselskab, bilvirksomhed. Der står og præsenterer fremtiden, når man snakker om alle de her store mål, og så kan de ikke engang få noget slides og have bøvl med den her klikker, men jeg håber, at du værdsætter, at den her præsentation er 3 timer lang, men jeg har virkelig klippet meget af det her og stillhed og alt sådan noget ud, som der er, når Elon præsenterer.
We have a plan to halve the cost per kilowatt hour. So first, before we get too far into it, let's talk about what is in a battery cell. We've got the cap and the can, negative and positive terminals of the cell. When you open that cell, you've got a tab connected to those terminals, what we call the jelly roll, which is the wound electrodes on the inside. To explain what's actually going on here, we've identified we've got anode, cathode, separator, positive and negative terminal. Watch what happens as we discharge the cell. Got lithium moving from anode to cathode, and then the reverse. When we charge the cell, anode moving from lithium moving from cathode to anode across the separator. This is the basic of what makes all lithium-ion batteries, no matter what the form factor is. So as you can see, we kind of swept the key figures of merit, how much we can reduce the cost, and how much vehicle range increases as we change the outer diameter of the cell. A bigger form factor, like anybody could make a bigger form factor.
Any fool could make a bigger form factor. We not any fool.
Yeah, exactly. There are problems as you make cells larger. In fact, supercharging and thermals in general become really challenging as you make bigger cells. And this was the challenge that our team set our sights on to overcome. Basically took the existing foils, laser patterned them, and enable dozens of connections into the active material through this shingled spiral you can see. With simpler manufacturing, fewer parts, 50 millimeter versus 250 millimeter electrical path length, which is how we get all the thermal benefits.
Yeah, this is important to appreciate. Like basically the distance that electron has to travel, is just much less. So you actually have a shorter path length in a large tabless cell than you have in the smaller cell with tabs. This is a big deal. So even though the cell is bigger, it actually has more power. The power to weight ratio is actually better than the smaller cell with tabs. This is quite hard to do. So it's nobody's done it before. So there's a whole bunch of things that we're keeping a little secret sauce here that we're not telling everything. I think it may sort of sound a bit silly to some people, but this is like, if for people that really know cells, this is a massive breakthrough. Elaborate on that a bit. It's like when the cell is going through the system, it has to keep stopping where all the tabs are. It's really a huge pain in the ass to have tabs from a production standpoint.
Yes. We get 5 times the energy with 6 times the power and enable 16% range increase, just form factor alone.
Yeah, it's pretty great. And just to clarify, that when we see these plus 16% or whatever the percentage range increases, these are the amounts due just to that particular innovation.
Yes. So
we'll list a whole bunch of innovations, and then when you add them up, you get a total improvement in energy density and cost. But these numbers are what refer to just this thing.
Yeah, and I want to stress, this is not just a concept or a rendering. We're starting to ramp up manufacturing of these cells at our pilot 10 gigawatt hour production facility just around the corner.
Yeah. So, yeah. It's a video of some of what's going on in the plant. Now, I mean, to be clear, it will take about a year to reach the 10 gigawatt hour capacity. I would say it's probably about a year before we get to the 10 gigawatt hour annualized rate with the pilot plant. And this is just a pilot plant. The actual production plants will be more on the order of maybe 200 gigawatt hours, maybe more over time.
But let's stack up everything we just saw at the cell level. So just the cell form factor change enables a 14% dollar per kilowatt hour reduction, just that cell form factor change. And now that you've been teased on this factory, we're going to go on and walk step by step through that factory and discuss a series of innovations there. Let's talk a little bit about what's in a cell factory. First, there's an electrode process where the active materials are coated into films onto foils. Then those coated foils are wound in the winding process we just talked about, where if you do have tabs, you have to start and stop a lot. Then the jelly roll is assembled into the can, sealed, filled with electrolyte, and then sent to formation, where the cell is charged for the first time. And we set out at every step of this process to try to take that inspiration we just showed and think about how we make those processes fundamentally better and more scalable. And when you're looking at this, you're like, wow, that's a lot of equipment for one step, especially when you consider that little speck next to the coating oven is a person. This is serious iron involved in making batteries. Wouldn't it be great if we could skip that solvent step, which is one of those dig a ditch and then fill it kind of things where you put the solvent in and then take it out and recycle it? You can see it here on a bench top. Literally, powder into film. As simple as that.
I mean, it's hard, actually, just to be clear. So, if this was easy, everyone would do it. So it's not like dry coating electrode is actually easy. It's actually very hard to do what appears to be a simple thing. It's insanely difficult to scale up.
But if you do scale it up,
yeah,
what you saw before becomes this.
Yeah.
So you can see the motivation. A 10 times reduction in footprint, a 10 times reduction in energy, and a massive reduction in investment. But as Elon was saying, simple is hard.
There's a clear path to success, but a ton of work between here and there. But this is a really profound improvement. Again, for people that know battery manufacturing. This is gigantic.
Yeah, and beyond the electrode, we continue to innovate on every other process step. So let's talk a little bit about assembly, which is next. The key to a high-performing assembly line is accomplishing processes while in motion, continuous motion, thinking of the line as a highway, max velocity down the highway, no start and stop, no city driving.
Exactly, no stoplights and traffic lights or anything. You want the highway.
I want the highway.
Yeah.
And through all of that development, we were able to get to the point where we can implement assembly lines, one line, 20 gigawatt hours, 7 times increase in output per line. And when you're thinking about scalability and pure effort, having one line be 7x the capability is just effort multiplying.
Yeah. So, yeah, you can sort of think about like the sort of the fundamental physics of a factory or something. Like, I think it's actually quite a lot like the rocket equation, where you've got basically in the rocket equation you've got your exhaust velocity and then the log of the start to end masses. So it's basically saying, you know, how fast are things going and what percentage of the factory volume is doing useful work. And conveyance does not count as useful work. Yeah, if you break the factory down into cubic meter sections and say, or smaller, it could be like 1 liter sections, is a majority of this volume doing useful work? You would be astounded at how bad most factories are. They're like maybe 2 or 3%, including our factory in Fremont. I think it is possible to get to at least 10 times that volumetric efficiency. So more like 30% ish, maybe more. And be 10x better, which means the factory can be 10 times smaller. And then the other thing is, how fast are things going through the factory? It's like speed and density.
For den ikke-tekniske, fysiske person kan det her måske godt lyde en smule nørdet og virke lidt uforstående, hvad Elon snakker om. Men helt kort forklaret, så Elon Musk er fysiker. Han tænker alting fra atomerne og op. Og samtidig så arbejder Tesla altid for first principle thinking. Det vil kort sagt sige, at Tesla de tænker fra atomerne. De tænker, hvordan alt kan gøres bedre. Lige fra hvordan man fremstiller materialerne, til hvordan man sætter dem sammen, til hvordan man udnytter pladsen i fabrikkerne, og til hvordan man kan skalere mest effektivt, mest billigt. Som man siger, så mange andre fabrikker, de bruger kun 2-3% effektivt af den plads, de bruger. Og det er det, at i fremtiden, der vil Tesla formentlig kunne lave en fabrik, der kan producere det samme, som de kan nu, men som er 10 gange mindre med det samme output. Fordi de tænker i altid, hvordan alt kan gøres mere effektivt. De ser det fra et fysisk standpunkt og ligesom tænker alt igennem i hele processen, og hvordan alting spiller sammen, og hvordan alting kan blive bedre. Det er altså meget unikt, og det er det, der gør, at Tesla har så stor en fordel i forhold til, hvor hurtigt det bevæger sig fremad, og hvor effektivt de er med alle deres processer. Som Elon Musk siger, den bedste proces er ingen proces. Det er svært at gøre det her simpelt, men det er altså super, super vigtigt, det som Elon fortæller nu.
The faster you go, like a factory that's moving at say twice the speed of another factory is equivalent to two factories, basically. And the company that will be successful is the company that with one factory can accomplish what other companies take 2 or 3 or 4 factories to do. So this is what we're trying to do here is say, okay, how do we with one factory achieve what maybe 5 or even 10 factories would normally be required to achieve?
We can design the entire machine to be one machine and remove all of these unnecessary steps.
I mean, basically Tesla is aiming to be the best at manufacturing of any company on Earth. This is the thing that's actually most important in the long run. But I think also for long-term competitiveness, eventually every car company will have long-range electric cars. Eventually every company will have autonomy, but not every company will be great at manufacturing. Tesla will be absolutely head and shoulders above anyone else in manufacturing. That is our goal.
Manufacturing is hard, and hard problems are fun to solve. Okay, now let's talk about formation. In a typical cell factory, formation represents 25% of the investment. And what is formation? It's charging and discharging cells and verifying the quality of the cell. The typical formation setup is you charge and discharge each cell individually. In our car, we charge thousands of cells at once. And we took our principle and our power electronics, leveraging Powerwall, vehicle battery management systems, and others, to dramatically improve the formation equipment cost effectiveness and density. 86% reduction in formation investment, 75% reduction in footprint.
So Essentially, what this translates to, based on what we know today, is about a 75% reduction in the investment per kilowatt hour. Basically 4 times better than the current state of the art to the best of our knowledge. I think there's probably room to improve even beyond that.
Definitely.
Definitely, yeah. You can see, like, basically, we can get a terawatt hour in less space than it took to make a gigawatt hour. 150 gigawatt hours. So this is pretty profound. It's like I would actually not have thought this was possible several years ago, but it allows us to make a lot more cars and a lot more stationary storage.
Der er virkelig mange gode nyheder, når det kommer til Teslas produktion af batterier i fremtiden. Men jeg prøver at klippe meget af det sådan lidt mere teknisk ud for den her video, og prøver bare at fokusere på de faktaerne og hvad det betyder for deres biler, for deres omkostninger, for deres produktion. Vi snakker nemlig rigtig meget omkring kemien af det og alt sådan noget, som jeg prøver at klippe lidt ud. Så hvis du er interesseret i at høre mere detaljer omkring batterierne, og hvordan de bliver lavet, produceret, fremstillet, materialer osv., så vil jeg anbefale, at du ser det fulde event. Og det er, igen, hvis du ikke er så teknisk, så er det måske en meget god idé at se det her først, og så se det fulde event bagefter. Men der er altså mange ting, jeg har klippet ud, og du kan måske også se, at jeg har fået nyt tøj på, fordi det er et 3 timers event, og når jeg sidder og klipper i det samtidig, gensætter osv., så tager det altså bare lang tid. Så jeg prøver sådan at holde det her til faktaerne. Hvis du gerne vil gå nørdet ned i detaljerne, så se det fulde event.
And not only is all of that manufacturing innovation fantastic for enabling scale, it's also an additional 18% reduction in dollar per kilowatt hour at the battery pack level.
But wait, there's more.
But wait, there's more.
Yeah.
So we have a manufacturing system. We've got a cell design. What are the active materials we're going to put in that cell design? Let's talk about the anode first. Let's talk about silicon. Why is silicon awesome? It's awesome because it's the most abundant element in the Earth's crust after oxygen, which means it's everywhere. It's sand.
Yeah. Sand is silicon dioxide.
Yeah. And it happens to store 9 times more lithium than graphite, which is the typical anode material in lithium-ion batteries today. So why isn't everybody using it? The main reason is because the challenge with silicon is that it expands 4x when fully charged with lithium.
Yeah, basically, with silicon, the cookie crumbles and gets gooey. That's basically what happens.
Good analogy.
Yeah.
What we're proposing is a step change in capability and a step change in cost. And what that really is to just go to the raw metallurgical silicon itself. Don't engineer the base metal. Just start with that and design for it to expand in how you think of the particle in the electrode design and how you code it.
Yeah, and I'm not sure if you saw this. Basically, $1 per kilowatt hours.
Yeah.
Basically, if you use simple silicon, it's dramatically less than even the silicon that is currently used in the batteries that are made today. And you can use a lot more of it.
The anode would cost, with this silicon, and the anode costs $1.20 a kilowatt hour.
Yeah.
And in the end, by leveraging this silicon to its potential, we can increase the range of our vehicles by an additional 20%, just this improvement.
Yeah, it gets cheaper and longer range.
Yeah, and when we take that anode cost reduction, we're looking at another 5% dollar per kilowatt hour reduction at the battery pack level. And there's more. Let's talk about cathodes. What is a battery cathode? Cathodes are like bookshelves where the metal, the nickel, the cobalt, the manganese, or aluminum is like the shelf, and the lithium is the book.
It's tough to exactly figure out what the right analogy is to explain cathode and anode, but a bookshelf is probably a pretty good one, in the sense that you need a stable structure to contain the ions. So you want a structure that does not crumble or get gooey, or basically that holds its shape in both the cathode and the anode. As you're moving these ions back and forth, it needs to retain its structure. So if it doesn't retain its structure, then you lose cycle life and your battery capacity drops very quickly.
And you can see nickel is the cheapest and the highest energy density, and that's why increasing nickel is a goal of ours and really everybody's in the battery industry. And that's what we've been working on with our high nickel cathode development, which has 0 cobalt in it. Leveraging novel coatings and dopants, we can get a 15% reduction in cathode dollar per kilowatt hour.
Yeah. It's a big deal. In order to scale, we really need to make sure that we're not constrained by total nickel availability. I actually spoke with the CEOs of the biggest mining companies in the world and said, please make more nickel. It's very important. And so I think they are going to make more nickel. I think we need to have a kind of a three-tiered approach to batteries. So starting with iron, that's kind of like a medium range, and then nickel manganese as sort of a medium plus, intermediate, and then high nickel for long-range applications like Cybertruck and the semi.
Det her var sådan en announcement, der var meget forventet af Elon lavede, nemlig at de begynder at lave forskellige typer af batterier til forskellige typer af køretøjer. Så sammensætningen af materialerne i batterierne vil afhænge af, om det er et super long range køretøj, som f.eks. semi-truck eller Cybertruck, eller det er deres nye kompakte bil, som de muligvis introducerer her senere i ventede.
Because a lot of people spend time talking about the metals. Actually, the cathode process itself is a big target. 35% of the cathode dollar per kilowatt hour is just in transferring it into its final form. And so we see that as a big target, and we decided to take that on. Here's a view of the traditional cathode process. Effectively, if you have the thing the mine intermediate metal, you can have the cathode. Then you make the intermediate, and at the end, you get that little bit of cathode and a whole bunch of wastewater and byproducts.
Yeah, it's insanely complicated. If you look at the total, like if you're just like, you know, it's a small world journey of I am a nickel atom. What happens to me? And it's crazy. Like you're going around the world 3 times. There's like the moral equivalent of like dig in the ditch, fill in the ditch, and dig in the ditch again. It's total madness, basically. And these things just grew up as they're just kind of like legacy things that it's like how it was done before. And then they connected the dots, but really didn't think of the whole thing from like a first principle standpoint, saying how do we get from the nickel ore in the ground to the finished nickel product for a battery. And so we've looked at the entire value chain and said, how can we make this as simple as possible?
And that's what we're proposing here with our process. As you can see, a whole lot less is going on here. We get rid of the intermediate, metal, water, final product cathode, recirculate the water, no wastewater at all. And when you summarize all of that, it's a 66% reduction in CapEx investment, a 76% reduction in process cost, and 0 wastewater. Much more scalable solution.
Yeah.
We can eliminate billions in battery-grade nickel intermediate production. It's not needed at all.
Yeah.
And now that we have this process, obviously we're going to go and start building our own cathode facility in North America and leveraging all of the North American resources that exist for nickel and lithium.
Det her er altså også en super vigtig pointe, som ingen andre bilfirmaer gør. Tesla, de tænker ikke, men det er sådan her, man altid har gjort, og sådan fortsætter vi bare. Tesla, de tænker altid, som jeg sagde, fra atomerne op, og hvordan man kan gøre processen så simpel og så billig og så effektiv som muligt. Så her igen, man har gjort noget i forhold til at lave de her katoder, som har medført en masse spildeprodukter før i tiden, som slet ikke har været nødvendigt, men det er bare sådan things has been done. Men det ændrer Tesla på. De finder på deres nye metoder, som er så effektive som muligt, og så opretter de da bare deres egen fabrik, hvor de kan gøre de her ting selv. Og det er også der, man ser med Tesla, at når en virksomhed er så langt fremme foran alle andre, så kan de ikke være afhængige af andres materialer, processer, innovationer osv. De bliver nødt til at lave alting selv, hvis de gerne vil have det så effektivt og så billigt som muligt, og fortsætte med at varetage deres førertrøje. Og det er sådan noget, der gør, at jeg synes, det er så fedt at være medejer af den her virksomhed, som er så innovativ og så langt fremadtænkende end andre, og ikke lade sig finde med status quo, men altid prøve på at finde en metode, hvor noget kan gøres billigere, bedre og mere effektivt. Uanset om det er at få bilerne til at køre bedre, eller det er software, eller det er materialerne, det er produceret af, eller materialerne, som man bruger til at producere materialerne. Alt bliver gennemtænkt for at finde frem til den mest effektive metode, som er mest bæredygtig, billig, hurtig osv.
We can reduce miles traveled by all the materials that end up in the cathode by 80%, which is huge for cost.
Yeah, I mean, to be clear, cathode production would be part of the Tesla cell production plant. So it would just be, basically, raw materials coming from the mine, and from raw materials in the mine, out comes a battery.
The way the lithium ends up in the cell is through the cathode, so then we should obviously on-site lithium conversion as well, which is what we will do using a new process that we're going to pioneer. That's a sulfate-free process again, skip the intermediate. 33% reduction in lithium cost, 100% electric facility co-located with the cathode plant.
There is a massive amount of lithium on Earth. So lithium is not like oil. There's a massive amount of it pretty much everywhere. So in fact, there's enough lithium in the United States to convert the entire United States fleet to electric. Like all the cars in the United States, there's like 300 million or something like that. Every vehicle in the United States can be converted to electric using only lithium that is available in the United States.
Discovered today.
What we already know exists.
People really haven't even been looking.
Yeah, people haven't been trying because it's just like widely available. So it is important to say, like, okay, what is the smartest way to take the ore and extract the lithium and do so in an environmentally friendly way? And we actually discovered again, looking at a sort of first principles physics standpoint, instead of just the way it's always been done, is we found that we can actually use table salt, sodium chloride, to basically extract the lithium from the ore. This is, nobody's done this before, to the best of my knowledge. Nobody's done this, and it's a sort of, all the elements are reusable. It's a very sustainable way of obtaining lithium, and we actually we actually got rights to a lithium clay deposit in Nevada. So
simply mix clay with salt, put it in water, salt comes out with the lithium, done.
It's pretty crazy.
Yeah. So we're really excited about this, and there really is enough lithium in Nevada alone to electrify the entire U.S. fleet.
Yeah, that's true. Actually, just what's in Nevada. That's basically so much damn lithium on Earth. It's crazy. It's one of the most common elements on the planet.
We will transfer the entire non-renewable fleet of both power plants, home heating and battery and industry heating and vehicles to electric. And at that point, we have an awesome resource in those batteries to recycle to make new batteries. So we don't need to do any more mining at that point, and you can see why.
Jeg håber, du hørte, hvad han lige sagde. Ellers lad os sige spil det igen.
To make new batteries. So we don't need to do any more mining at that point, and you can see why.
Så de kan altså genbruge materialerne fra de eksisterende batterier, som Tesla i forvejen genbruger 100% af, og de behøves ikke lave
need to do any more mining at that point, and you can see why.
Don't need to do any more mining at that point. Det vil sige, der behøves slet ikke at laves mere mining. De kan genanvende alle de batterier, de har i deres biler, i deres airconditioner og kølesystemer, og i deres stationære batterier i solcelleanlæggene osv. Så igen, endnu flere gode nyheder for Tesla, og gode nyheder for fremtiden, og for klimaet, og for den bæredygtige vedvarende energi.
The value of the material coming back from the vehicle versus the ground, you'd always go to the vehicle. And we recycle 100% of our vehicle batteries today. And actually, we are starting our pilot full-scale recycling production at Gigafactory Reno next quarter.
I mean, to date, it's been done by third parties, but we think we can recycle the batteries more effectively.
The recycling resource is always 10 or greater years delayed because batteries last a really long time. But eventually, it is the way that all resources will be made available, and that's why we're investing in this recycling facility in Nevada.
Yeah. Long-term, new batteries will come from old batteries once the fleet reaches steady state.
All of the benefits that you just saw are added to this benefit of a 12% reduction in dollars per kilowatt hour at the battery pack level. But there's one more section. Take it away, Elon.
Great. So there's an architecture that we've been wanting to do at Tesla for a long time, and we're finally figured it out. And I think it's the way that all electric cars in the future will ultimately be made. It's the right way to do things. So it starts with having a single piece casting, or a single piece casting for the front body and the rear body. And in order to do this, we commissioned the largest casting machine that has ever been made, and it's currently working just over the road at our Fremont plant. We have the it's pretty sweet, making the currently making the entire rear section of the car as a single piece, high pressure die cast aluminum. And in order to do this, we actually had to develop our own alloy because we wanted a high strength casting alloy that did not require coatings or heat treatment. This is a big deal for castings, especially with a large casting. If you heat treat it afterwards, it tends to deform. It kind of does this like potato chip thing. So it's very hard to keep a large casting to have its shape. So in order to achieve this, there was no alloy that existed that could do this. So we developed our own alloy, a special alloy of aluminum that has high strength without heat treat and is very castable. So that's a great achievement of our materials team.
Igen, hvor mange andre bilfabrikanter laver lige og fremstiller deres egen aluminium, fordi de kan gøre deres bilproduktion mere effektiv. Det er altså meget unikt, alle de her ting Tesla har gang i, og hvis du gerne vil vide endnu mere, kan jeg også anbefale, at du ser nogle af Sandy Munros videoer, der er en af verdens ledende, uvildige bileksperter, som flere gange har nævnt, hvordan Tesla er 5-10 år længere frem end alle andre, og når han ofte analyserer biler fra forskellige virksomheder, så siger han med Tesla, hvis han siger, at der er nogle forbedringer, et par måneder, så er det i produktion. Hvorimod ved andre bilselskaber, der kan det gå år, fordi der er så meget bureaukrati, administration og processer osv., og det kommer nærmest aldrig ud til forbrugerne, de forslag han laver. Men Tesla, de optimerer hele tiden deres biler, deres produktion, fra det A til Z, fra hele livscyklusen tænker de det igennem. Og nu har de så produceret deres egen største megacasting, der gør, at de kan producere fronten og bagdelen af deres Model Y, formentlig senere også Model 3, i 1 eller 2 stykker, tror jeg det er, i stedet for hundredvis af stykker. Altså igen, de kan lave mange flere biler hurtigere og billigere og bedre, og de kan reducere omkostningerne, og de udvikler også bare lige deres egen aluminium undervejs også.
In fact, in general, we've got a lot of advanced materials coming for Tesla, that new alloys and materials that have never existed before. So you're basically making the front and rear of the car as a single piece, and that then interfaces to what we call the structural battery, where the battery for the first time will have dual use. The battery will both have the use as an energy device and as structure. This is absolutely the way things are done. In the early days of aircraft, they would carry the fuel tanks as cargo. So the fuel tanks actually were quite difficult to carry. They were like basically worse than cargo. You had to kind of bolt them down. Then somebody said, hey, what if we just make the wing tanks, what if we just make the fuel tank in wing shape? All modern airplanes, the fuel tank, your wing is just a fuel tank in wing shape. This is absolutely the way to do it. And then the fuel tank serves as dual structure. And it's no longer cargo. It's fundamental to the structure of the aircraft. This was a major breakthrough. We're doing the same for cars. So this is really quite profound. The non-cell portion of the battery has negative mass. So we save so much mass in the rest of the vehicle. We save more mass in the rest of the vehicle than the non-cell portion of the battery. It also allows us to pack the cells more densely. It effectively glues the cells to the top and bottom sheet. And this allows you to do shear transfer between the upper and lower sheet. Just like if you have like a Formula One craft or like a racing boat, and you have carbon fiber face sheets and say aluminum honeycomb between them, this gives you incredible stiffness. And it's really the way that any super fast thing works is you create basically a honeycomb sandwich with two face sheets. This is actually even better than what aircraft do, because aircraft do not do this, which makes for an incredibly stiff structure, even stiffer than a regular car.
Yeah.
In fact, if this was a convertible that had no upper structure, it would be stiffer than that convertible would be stiffer than a regular car. So it's just really really major. It reduces the probability of a side impact potentially contacting the cells, because any kind of side impact has to go further in order to reach the cells. The car maneuvers better. It just feels better. You don't know why, but it just feels more agile. So it's really cool. This is really major. Like I said, so 10% mass reduction in the body of the car, 14% range increase, 370 fewer parts. So, I mean, I really think that long term, in any cars that do not take this architecture will not be competitive.
So we're looking at over 50% reduction in investment per gigawatt hour, 35% reduction in floor space, and we'll continue to improve that as we make the vehicle factory of the future.
Major improvements on all fronts, from the cell all the way to the vehicle.
And in addition to the improvements we just said on enabling additional range and improving the structural performance of the vehicle, it is worth another 7% dollar per kilowatt hour reduction at the battery pack level, bringing our total reductions now to 56% dollars per kilowatt hour.
Yeah.
All right, so stacking it up, we're not just talking about cost or range. We've got to look at all the facets. Range increase, we're unlocking up to 54% increase in range for our vehicles. and energy density for our energy products. 56% reduction in dollars per kilowatt hour at the battery pack level, and a 69% reduction in investment per gigawatt hour, which is the true enabler when we talk back about how do we achieve this scale problem here.
I think it's pretty nice that investment per gigawatt hour reduction is 69%. I mean, who would have thought?
Yeah, just happened to happen out that way. Yeah.
I mean, 0.420%, of course. What this enables us to do is achieve a new trajectory in the reduction of cell cost. And now, to be clear, it will take us probably a year to 18 months to start realizing these advantages, and probably to fully realize the advantages, probably it's about 3 years or thereabouts. So, it's not like if we could do this instantly, we would. But it's really.
Ja, så 18 måneder, måske mere 3 år før alle de her forbedringer, det vil være i produktion ved Tesla. Der er mange, der har spurgt, om jeg vil sælge Tesla-aktier nu efter Battery Day, om det har været en skuffelse, og man kan se, at aktiekursen er faldet en del efter Battery Day. Men det er, som jeg også nævnte tidligere, meget forventeligt. Folk, de køber det, buy the rumor og sell the fact, så de køber det med høje forventninger op til Battery Day, og sælger igen på grund af de forventede kortsigtede gevinst. Så lige nu er der altså flere, der sælger Tesla-aktier, end der køber, og derfor der falder aktieprisen. Men for mig, som en investor og ikke en spekulant, det vil sige, at jeg har ingen planer om at sælge Tesla de næste mange år, der er det her altså bare en kæmpe god nyhed. Og hvorfor er den her tilbagegang i aktiekursen egentlig bare får mig lyst til at købe flere Tesla-aktier til en billigere pris?
I think what this bodes for, it just really bodes well for the future, and means that the long-term scaling of Tesla and the sustainable energy products that we make will be massively increased. So, what tends to happen as companies get bigger is things tend to slow down. Actually, they're going to speed up.
And they have to speed up if we're going to accelerate the transition to sustainable energy.
I mean, long term, we want to try to replace about, at least 1% of the total vehicle fleet on Earth, which is about 2 billion vehicles. So long term, we want to try to make about 20 million vehicles a year.
When we talked about 3 terawatt hours by 2030, the problem is a 20 terawatt hour problem. So everybody needs to be accelerating their efforts to accomplish these objectives. Doesn't matter where you are in the value chain, there is a ton to do. You need to rethink from first principles how you do it so that you can scale to meet all of our objectives.
What does this mean for our future products? We're confident that long term we can design and manufacture a compelling $25,000 electric vehicle.
Og så fik vi første hint til en ny Tesla-model, at de på sigt kan producere en eftertragtet elbil til $25,000 eller rundt regnet 150.000 danske kroner for en Tesla. Hvor mange tror du ikke vil gå ud og købe en Tesla i dag, hvis man kan få en til 150.000 kroner? Det bliver altså spændende at se den her Model C Tesla Compact Car, som de er i gang med at designe blandt andet i Kina. Og måske der også bliver en designet en her i Europa til det europæiske marked, når den kommer på markedet, og hvad det vil gøre for Teslas bilsalg. Du ved det sikkert godt allerede nu, men Tesla er ikke all about luksuriøse biler, men de bliver bare nødt til at starte med biler med en høj profitmargin, for at de kunne fortsætte med at lave billigere og billigere biler, som de får mere economies of scale, og dermed kan opnå deres mission med at overføre verdens energi til vedvarende energikilder. Men det kan man altså ikke med at starte med at lave en billig grøn bil, som ingen vil have. Man er nødt til at starte med de eftertragtede biler, og så kan man, som man vokser, lave billigere og billigere biler, ligesom Tesla også hele tiden har gjort, nemlig sat priserne ned på deres biler og introduceret mere tilgængelige biler for det brede marked.
This has always been our dream from the beginning of the company. I even wrote a blog piece about it because our first car was an expensive sports car, and then it was slightly less expensive sedan, and then finally sort of a mass market premium, but like the Model 3 and Model Y. But it was always our goal to try to make an affordable electric car, and I think probably, like I said, about 3 years from now, we're confident we can make a very compelling $25,000 electric vehicle that's also fully autonomous.
How much less expensive it is to own an electric vehicle.
Yeah.
So actually, it becomes even more affordable at that $25,000 price point.
Yeah. So we have and extreme performance and range. And we should probably talk about the Model S Plaid. What about that? Yeah.
What? Så Model S Plaid version, det er en Tesla Model S med 3 elektriske motorer til mit kendskab, som kan klare 0-100 km/t på under 2 sekunder, og med over 1100 hestekræfter. What? Jeg tror, jeg skal tjene nogle flere penge. Vi skal vist ikke have Model 3 længere. Okay, spændende. Lad os se, hvad Elon har at sige om Model S Plaid.
So, yeah, anyway, we took the latest Plaid out to Laguna Seca on Sunday. It got a minute 30, and we think probably there's another 3 seconds or more to take off that time. So we're confident the Model S Plaid will achieve the best track time of any production vehicle ever, of any kind, two-door or otherwise. And you can order it now, and it's available basically end of next year.
Actually, I don't know how we're getting the questions.
Actually, I don't know either. Is somebody going to read them to him? Okay, well, you could just like... You can maybe get out of the car for 2 seconds and yell it at us. I don't know. Hey, how do we get the questions?
Oh, they're mics. Okay, wait for the mic.
Oh, there are mics. Okay, great.
All right.
Okay, we'll definitely need to give people mics because otherwise there's no way.
How does the ICE industry look like for in the future?
Well, I don't think there will be an ICE industry long term. So, yeah. For the Cybertruck, the orders are gigantic. So, and we have like, I don't know, well over 500,000 orders. I think maybe 600,000 or 600,000. That's a lot, basically. We stopped counting. So I think there's probably room for, I don't know, at least like a unit volume of like 250 to 300,000 a year, maybe more. We'll probably make an international version of the Cybertruck that'll be kind of smaller, kind of like a tight Wolverine package. It'll still be cooler, but it'll be smaller because you just can't make a giant truck like that for most markets.
Is once we do get to the 25K car, the ownership cost of that car is incredibly lower than the prior car. And then on the solar side and wind, with the cost of solar and wind coming down and with batteries coming down with them, the actual cost of energy on the grid is going down. So we're sort of moving towards a sustainable, lower cost future.
A sustainable energy is going to be lower cost, not higher cost than fossil fuels. So there's a lot of companies in China that I think are doing great work with electric vehicles and also with stationary storage. Although we don't see that much in the US yet, but I think probably we will in the future. I don't know. I mean, obviously, we're doing everything we can to encourage other companies to move to sustainable transport and also, make stationary storage batteries. We opened up, made our patents freely available. We really try to tell these companies, hey, you really need to do this or you won't exist in the future. But they don't believe it, So, I mean, we've talked until we're blue in the face. What are we supposed to do? But we really are hopeful that other companies will also do what we're doing, and that will make a sustainable future come sooner. Over time, we'll see all modes of transport, with the ironic exception of rockets, transition to sustainability, or to electric, basically. On the rocket front, what we're planning to do is about 80% of Starship is liquid oxygen, and we're actually already running a power line to be able to use wind power to create the liquid oxygen. So we're making some decent progress on sustainability on the rocket front, but there's just no way to have an electric rocket, and it's important for the future of life and consciousness that we become a multi-planet species. So got to keep doing that.
I think that they've been sort of sitting back being like, are you going to grow like crazy? And we're like, yeah, we're going to grow like crazy. And then I think this indicates we're going to grow like crazy, and that's what the miners want to hear, and then they'll go make the investments.
As we go to a more autonomous future, the importance of entertainment and productivity will become greater and greater. I mean, to the degree that if you're just basically sitting in your car, the car is fully autonomous and driving somewhere. It's sort of like being the car is essentially your chauffeur. The things that become important are, okay, well, let's have good entertainment, and if you want to do some productivity stuff, then that actually starts to become much more important because you're no longer spending your attention driving the car. So it will be extremely important in the future. The first one I think we already answered. Like if we're able to make enough cells, which we'll try to do, or we will supply other companies. It's definitely not an intentional effort to keep the cells to ourselves. If we can make enough for other companies, we will supply them. And we're trying to do the right thing for advancing the sustainable energy, whatever that is. That said, like we can certainly do vehicle to grid. I think we can basically enable that with software in Europe or something, right? I think very very few people would actually use vehicle to grid, and we actually had that with the original Roadster. We had vehicle to grid capabilities. Nobody used it.
How do we find the engineers to do everything we're saying?
How do we find the engineers to do all these things? I think Tesla has a good reputation for doing exciting engineering, and that tends to attract a lot of the top engineers in the world because they know that their efforts at Tesla will really serve the greater good, and we're super hardcore about engineering. Tesla is like first and foremost an engineering company. It's like hardcore engineering is what we do. There's various surveys done of engineering schools. Where do you want to go? Like what's your top choices? And actually, the top two choices last few years have been Tesla and SpaceX.
If you are motivated to solve some of these problems, which are the hardest problems in the world to solve, that really fundamentally enable the future we all need, please reach out.
Try to give back as much as possible to the customers. It's not like it's not like Tesla's profitability is crazy high. Our average profitability for the last 4 quarters is like maybe 1%. So just to be clear, it's not like we're minting money. Our valuation makes it seem like we are, but we're not. And just making a car super desirable but expensive does not mean they can afford it. So it's absolutely critical that we make cars that people can actually afford.
When do you expect Tesla vehicles to beat ICE vehicles on initial purchase price? I think a way to answer that question is, in the classes of vehicles we sell today, we're already doing that.
Yeah, we're already pretty close. And then factoring in total cost of ownership, the fact that electric vehicles require much less servicing and are way cheaper to run. When you look at like total cost of ownership, and you can obviously lease a car. So if you just like lease a car or get a loan for a car, you've got your sort of monthly payment, and then your cost for either gasoline or electricity, and your cost of servicing, and the fully considered cost of an electric car is much less than a gasoline car of the same nominal purchase price.
I just want to reiterate the fact that this is a massive problem.
Massive problem.
And it seems like Tesla's on its way and ahead, but we need everybody's help because it's everybody's planet.
And obviously, if you care about solving sustainability and doing hardcore engineering, definitely come work at Tesla. All right. Well, I guess thank you everyone for coming. I hope you liked the presentation. Very exciting future ahead. We're going to work our damnedest to transition the world to sustainable energy as quickly as possible, and your support and help is key to that success. So thanks again, super appreciated, and look forward to the next event. Thank you.
Thank you.